Just to begin, I want to thank everyone for coming to my workshop, taking an hour and a half or so out of your day. And hopefully, you come out of this a little bit more confident as a game developer or aspiring programmer and learn something new, teach you a skill that you might like. So, my name is Doc Kim. I'm a IT manager for a nonprofit charity in London, Ontario. I'm also a final year student studying game development at Algonquin College up here in Ottawa. If you want to learn more about game dev, you can always check out my YouTube, which is Darove. There's no videos on it right now, but I do have a lot of planned content to release over this summer. Just small, short tips on game development. I also have a website called dogkim.me under construction. Hey CPT, under construction, and over time I'm gonna upload more free games on there if you want to try out the games I've made. And also here is my LinkedIn. With my LinkedIn, it's really good for networking. I can follow you guys if you ever create your own games and see the content that you create from what you learn from my workshop. Some in past month is like this puzzle game. You mean to stalk you? I don't know about that, Chief. I made a puzzle game where there's like all these hieroglyphs and stuff like that. I made it over 2 days in a game jam, believe it or not. And a current game I'm working on is a gladiator game, um, just to build up my portfolio and use the skills I learned while I was in college, refining my skills and all that. But a thing about game development, at least a game development career, is a big part of securing a job or knowing who you are is your portfolio. You gotta have a lot of games under your belt. So, just for content for this workshop, we're gonna learn what is Unreal Engine, what games are have been created with Unreal Engine, and what can you do with Unreal Engine. We're also gonna, throughout the workshop, learn how Unreal Engine makes game development easier, at least compared to making your own game engine. We're gonna learn how to do gray blocking. We're gonna learn a little bit of blueprint programming, and at the very end, we're gonna learn how to succeed as a game developer. So, what is Unreal Engine 4? Unreal Engine 4, primarily, is a game engine. It's a collection of development tools enabling the development of games rapidly. So, it's a lot faster than just creating your own tools. For example, if you want to have particle effects within your game, you can just import it. If you want to have a sound system, a complicated sound system within your game, you can just import it. It's already been done by the Epic Games developers. If you want like all these certain cool stuff you see in games like Borderlands, you can just import it. It's really that easy. However, given Unreal Engine's popular rendering system and how great it is, it's spread to other industries too. For example, architecture, automotive, and film. For architecture, mainly when architects make blueprints, they want to make a render, usually in AutoCAD, of what their final building would look like. Sometimes it's rendered in Unreal Engine 4 to show how neat it would look to property investors. For automotive, usually when you see the commercials of vehicles, it's almost entirely rendered by a computer, usually using Unreal Engine. It's actually what my cousin does for a living. She does it with Ford. And that's actually a reason why you can't see. I don't know if you guys tried this, but if you try to look through the driver window in the commercials, you can't see a person driving the vehicle because the vehicle's not real, believe it or not. And film. It's used a lot in the film industry, and as the film industry leans more towards using CGI as it becomes more available and easier, um, it's very popular in the film industry right now in Hollywood. For example, if you've seen The Mandalorian on Disney Plus, that a lot of that was rendered with Unreal Engine. And right here is a GIF of when I went to a game conference the other week. I actually got a chance to speak to one of the Epic Games developers, and he is showing off Unreal Engine 5, live facial recognition, and how easy it is to just kind of like use your phone camera. Believe it or not, this is with his iPhone X phone camera. Um, face tracking and stuff like that. It's really creepy. A great thing about having everything created for you is the documentation. So everything is documented for you right here in the Unreal Engine API references. If you ever want to learn how to use certain things like the sound system or particle effects, you just type it in the search documentation tab right there. So, what games have been created with Unreal Engine? So, the entire Borderlands franchise was created with Unreal Engine. Borderlands 1, 2, and 3. It's a really great game if you guys haven't played that before. Ark Survival Evolved, Hellblade Senua's Sacrifice really showed off its motion tracking ability, and Valorant and Fortnite. These are probably two most popular games right now, Valorant and Fortnite, created with Unreal Engine. So Unreal Engine has a wide range of games created. It can be 3D, it can be 2D, it can be a shoot and loot, it can be a battle royale, or it can just be a puzzle game. It can even be like a simple story game. And that's a really great part about Unreal Engine. It's really limited by your own imagination, your ability to do problem solving, and your ingenuity. If you can think of something, break it down into smaller steps so you can program it, you can make it in Unreal Engine. So, what can you do in Unreal Engine? There's a lot of different jobs that are delegated in a game company, but two that are absolutely essential to develop video games is a gameplay programmer, a person that creates the gameplay mechanics and the logic behind games, and a level designer, a person who places assets created by the artists, 3D modeling artists, and the programmers, so different mechanics created by the programmers, and they create a mission or a level for the game. And that's exactly what I'm going to have you guys do today. I'm going to have a little bit of a simulation of what it's like to be of a gameplay programmer and a level designer. So to start, let's launch Unreal Engine. So launch the Epic Games launcher, go to the Unreal Engine tab, Library tab, and click Launch. Awesome. I'm just going to give everybody about a minute to get to this browser here. If you have any questions, feel free to type it in Discord, or even feel free to unmute yourself. Yeah, level design can be very difficult because it has a lot of psychology behind it, believe it or not. Oh, it's just verifying? That's all cool. I will be explaining a lot of the menu stuff, so you'll have a lot of time to load up and catch up. I'll just give you guys another minute. Yeah, this workshop's now streamed in HD thanks to free server boosted stuff, which is great because it came from Epic Games, and we're using the Epic Games Unreal Engine. A message from our sponsors. All right. So hopefully most of you have gone to the Unreal Project browser. Since we are creating a video game, we're going to click on Games. And we're just going to hit Next. So now it's asking us for a template. Usually, when you're a seasoned veteran, you would start with blank because you want to create most of the stuff yourself. However, we're going to be using third person because we're going to make a third person perspective 3D platformer. So once you have third person selected, it will be in the top row, second from the right. Click Next. Once you have that done, this will be your project settings. At the very first option, it says Blueprint. We're just going to click on the drop down menu, which is right here, and we're going to select C++. So what this does is we're telling Unreal Engine we want it to create Visual Studio files. So if anyone in your team, or even if you at some point want to work on your project in C++, it's really good to have those Visual Studio files created. Everything else we're gonna keep at the same. So we're gonna make it maximum quality because scalable 3D or 2D is mainly for mobile games, which we are not creating. We are creating the game for a desktop, not for like a phone or a tablet. We're gonna keep the starter content because there are some shapes and textures in there we may be utilizing. And we're gonna keep ray tracing disabled because unless you're able to manage to grab a 3080, we'll be sitting here for like 2 hours trying to render the complex lighting system ray tracing has. Now here, it's very important to know where your project is located, and later on, I will have you guys refer to this. But for now, just browse where you would like your workshop to be located. So I usually keep mine on my F drive. I put in my personal projects files, and I just keep it here. And I'm just gonna name mine. Oops. I'm just gonna name my project Curious Workshop. And I'm just gonna give you guys a minute to do that as well. All right, how are you guys doing? Looks like one of you guys are still verifying. Yeah, it is true. Godot engine will not take this long. It's because they're an open source game engine created mainly by the community. However, unfortunately, they don't have the sizable engineering team Epic Games has. Oh, yeah, 4% left, and Emily's all done. Yeah, that's actually a great idea. If everyone is done, just give a thumbs up or something into the workshop chat here, just so I know you're up to speed. If you have any questions, feel free to ask, and I can go back and answer them. Awesome. I'm seeing some thumbs up. It's possible. I'm not sure what computer you're running, but I do have a lot more explaining once we open up Unreal Engine. I'll be explaining the UI, so who knows? But you can always go back and watch the recording, and you can just follow along. Yeah, I believe Steven is recording, and he's going to upload it to the Curious YouTube channel. Awesome. So I saw some two thumbs. I'm going to assume everyone's all caught up. So again, set to C++. Choose the file location of where you'd like your project to be located, and name your project. So I just named mine Curious underscore workshop. And the big green button right here, I'm gonna click create project. And this is just gonna take a minute. Awesome. So we should see Visual Studio open and also Unreal Engine, hopefully. Luckily, I had it on SSD, so it's fast for me. But just send a thumbs up into chat again. Or actually, let's make it different. Send a rocket ship into the workshop channel. once you have Unreal Engine open. Oh, sweet, you guys got some gaming PCs. All right, so Unreal Engine actually, our previous presenter asked for the same thing. Yeah, because rocket ship is speed or something. I don't know. Maybe it's just like psychology or something. So Unreal Engine kindly created us a demo for the template. There's this huge play button right here, so let's click it. And as you can see, a lot of the things for a 3D platformer or a third-person game has already been created for us. We have a character, we have the map, we have the camera setup, we have the control setup. All these things might seem small to you because if you've been playing a lot of video games, those things are just kind of right there. We all expect it to be right there. Um, However, programming these things actually take a while. So I will introduce you to the user interface of Unreal Engine. So at the very left here, we have the Place Actors panel. The Place Actors panel is like a toolbox. You can easily drag in different things. So for example, this cube, this player start. The player start is where the player would spawn. Different shapes, different triggers. We can even put in lights if we're working on a dungeon, for example, where it's nice and dark. We can put in camera rigs if we're making a story-based game, like the Telltale games. We can put in visual effects, like post-processing if we're making a horror game and we want a lot of fog and gloominess. And we can put in geometry, which is what we'll be working with a lot for this platformer, for something called gray blocking. And some volumes as well, and some more classes. At the bottom here, we have the content browser. So the content browser is how we browse through our files. So it's just like the Windows File Explorer, but it's already built into our engine, which is pretty cool. We have the add import where we can create different things. We have the save all, and we have a search bar. There is a little button right here to the very left of the top, or top left of the content browser, called Show or Hide Sources panel. We're going to go ahead and click that so we can see the file hierarchy. It will make it a lot easier to organize your files and search for different things. To the right, we have the details panel. So if we have something selected, for example, this cube, it will show all the properties of that cube. So we can see its location, its rotation, its scale, its mobility, and different options as well. Another thing, right down here in the middle, this is the viewport. If you're wondering how I'm moving around, if you just right click, you can move your mouse around to pan throughout the map. And if you use WASD, you can move around the map. If you find yourself moving too quickly or too slowly, on the very top right, there is something called a camera speed, and there's a little slider you can adjust to go slower or quicker. Oh, that's a little bit too fast. And finally, on the right here, we have the world outliner. So the world outliner is a hierarchy that shows everything inside of your level or your map. So if I'm working on a particularly large map, say I'm all the way over here and I want to work on my cube, but I don't know where my cube is, I can search for my cube and I can press F and get there. It makes it really convenient to find things inside your viewport and also edit their properties in the details panel on the fly. Right up here down the middle is a bunch of quick commands for Unreal Engine. So for example, saving. Saving is really important in game development, along with other things as well, because you put in a lot of work that you do not want to lose. Source control as well. We won't be using source control, but usually you always want some kind of source control and not just game development, but all things programming related, just so you don't lose a fresh copy of your project. Mainly, people use GitHub. Some people use Perforce. There's a lot of different options you can use, but we will not be doing that today. There are different modes we can work with. So right now we just have the select mode, so we can just move things, resize them, or rotate them. To do all that, you can see the tools on the top right here. So for move, rotate, and resize. A really easy and quick way to do that is learning the hotkeys. So moving is W, rotating is E, and resizing is R. And once you learn that, all the buttons are right next to each other, it's really easy to quickly block out what you want the level to look like. So to get started, I'm gonna have you guys create a new level. So we're gonna go to File. We're gonna go to New Level, and we're gonna make a blank level. I'm not gonna save anything here because I didn't make anything I want to keep. Go ahead and give me a smiley face into chat if you've created your new level. Again, you want to go to File on the top left, right here, and there's a new level option right here, or you can press Control N to create a new level. A menu will come up, and we're just going to go with default because we don't want anything in there. Awesome. I'm going to assume most people have a new level created. So we start with a bare basics. All we have in here is the floor and some lighting equipment. We also have the player start, so somewhere for our player to spawn. So to get started on our 3D platformer, we're gonna want another floor to get to. So a cool thing is if I select a floor and I press W to make sure I'm on my move tool, I'm gonna hold down Alt before clicking down on the red arrow, and I'm gonna drag this out to about 2000x. You can really have it how far you'd like. I'm just very particular on numbers. So again, we're just gonna select our floor with our move tool by pressing W. Press Alt, hold down the red arrow, and pull out to about 2000x or so. Just far enough so our player cannot reach. Now, once you've created the second floor, you're going to want to be able to have a platform to jump on to get to the next floor. To do that, on your Place Actors panel on the left side of your screen, you want to have Basics selected, and you want to pull out a cube. With that cube, I'm just going to pull it out roughly in the middle between my two floors. Then I'm going to press E. I'm going to press R and make what I think a platform should look like. And once you've done that, you can play test if your platform is correctly sized and correctly proportionate to the next floor. Now you can travel between the two floors. But hold on. It's kind of hard to see this platform between the two floors because the bottom of the skybox is a cloud. So let's change its color. Before changing the color, it's really important to be organized because when you're a game developer, you're dealing with thousands of files. So on our content browser, we're going to right-click the content folder, and we're going to make a new folder. I'm going to name this new folder Materials. So once you have the Materials folder created, we're going to right-click and make a new material. I want my material to be red, so I'm going to name this material red. And once you have your material created, I'm just going to give you guys a minute to do that. You're going to want to double click your material. So again, you're going to want to go to Content Browser, right-click the content folder, and then click New Folder. And I'm going to name it Materials because that's where I'll be storing my materials. I can't name it that because I already have one. And then inside the Materials folder, right-click the empty space and create a new material. So inside the material editor, we have a lot of different options. So base color is where we connect our texture. Since it's just going to be a solid color, it's just called base color. Metallic controls how metal-like your surface is going to look like. Specular helps define what portion of your texture is going to be non-metallic. Roughness is going to make the material look rough. It'll make it like diffuse light or very matte and non-reflectable. So since I just want my color to be red, I won't be using base color. And to make it red, I'm just going to right-click anywhere in this empty space, and in the search bar, I'm going to type constant 3 vector. So constant 3 vector. And this box comes up. When you have this box, double click the black panel. And since I named it red, I'm just going to make mine red. So you have the color wheel, and you can play the colors in here, and you can see what your color is going to look like where it says new, or you can look at here as well. It is also possible to just paste a hex number or a hex code in one of these value boxes. When you're working with a game development team, you usually have a saved amount of hex codes to stick to a certain theme. So it's really important to use those tools. So once you have your color, you want to drag out from the node here and connect it to base color. And now we can see right here in our viewport that it's red. And that's the color I happen to like for this one. So I'm going to hit save, or I can press Control S and have it saved. Once you have it saved, you can select your cube. Since your cube has not changed colors, it's because you haven't applied it yet. So you need to select your platform or cube and go down in the details panel to where it says materials. And in search assets, I'm just going to type in red. And now it's red. Now it's a lot easier to see compared to the white of the skybox. But oh no, I fell off the platform, and now I'm falling forever into the void. That's not great for a video game. What I want to do is I want to die after falling a certain distance. To do that, at the middle of the screen, or a top bar, there's something called settings. So we're going to click the drop down menu, and we're going to click World Settings. Once you've clicked World Settings, a new panel is going to pop up on the right side of your screen, and all these options are going to come up. The one we are focusing on is this Kill Z property. I'm gonna set to negative 1000, and I'm gonna test what that's like. Yeah, that's pretty good. So you want to. Oh, and I'm pressing escape to exit from the playtest. So you want to go to settings, open your world settings, go to Killzy, and set it to a number you think is appropriate. For me, that's negative 1000. So now we have a working platformer, and we haven't done any programming yet. But the thing is, just kind of jumping on stationary platforms, it's kind of boring. So for my second platform, I'm going to drag it out. But this time, I'm going to be using my details panel to set its position. I'm going to set this to about 7,000. And that's that's pretty far. So I'm gonna want to be able to make some kind of moving platform that would transport me from this platform to that platform. And I'm gonna do that using C++. But before we get started on programming, what we should do is go to our content browser, and right-click content once again, and make a new folder. I'm gonna name my folder maps because I want to store this map in here. I haven't saved my map yet. So once you've done that, let's do save current. And I'm gonna save it to maps. So I'm gonna double click maps, and I'm gonna name my level main underscore map because it's my main map. If you plan on expanding on this and you want to make multiple puzzles or multiple levels, you can name it level 1 and you can number it like that. So now that everything is saved, I want to create some C++ files. To do that, I'm gonna go select my C++ classes, and then I'm gonna go to this bright green button drop-down menu. So I'm gonna hit the drop-down menu, and I'm gonna press New C++ class. And I'm just gonna hit New C++ class. Once you have that done, you wanna go to Actor. So just select the actor. An actor is an object that can be placed or spawned in the world. Since the moving platform is going to be an object that we want to be placed in the world, that's the most appropriate for what we want. And I want to name my actor. I want to name my actor moving underscore platform, just to keep it very simple and straightforward to what my classes are going to be. Once I have that, I'm gonna go to create class, this bright green button right here. And just to repeat myself, I want to go to the bright green add/import button on the content browser. Oh, actually still compiling, some frozen. And I want to make a new C++ file. And I want it to be an actor. I want to go and name it moving platform. And once you have that done, give a thumbs up into chat. It can take a little while to create these Visual Studio files. If you have any questions, feel free to unmute or type in the workshop chat. Oh yeah, that's fair. I'll just go ahead and continue then. So once you've created your new classes, Visual Studio is going to say a file modification has been detected. So what you're going to want to do is hit reload all. And now everything's fine. It just needs to refresh. So what Unreal Engine did for us is create these Visual Studio files. It created a CPP, which is C++ file, and a .h header file. So if you've never programmed in C++ before, no worries. This is a great place to start. We're going to start in the header file. So this is a class. So we're making an object called a moving platform. And what we're doing is we're making it inheriting publicly from an actor. So when we define our variables, we can make it public, protected, or in this case, private. Public allows anyone anywhere to see what variables moving platform contains. Protected only allows people inheriting to see what variables it contains. And private allows no one except for itself to see what variables it contains. Since it's a moving platform, we're going to want to make it have a speed. I'm making a float because a float is a number that has decimals. And since it's going to be inside Unreal, I'm going to write something called uProperty. So what uProperty does is it allows Unreal Engine to recognize this variable, and whatever you put inside these brackets, it will follow these variables. So I'm going to say edit anywhere. And the reason I'm doing that is for level designers. This way, they don't have to open up Visual Studio to edit my variable speed. They will be able to edit it from within Unreal Engine. So once you have uProperty edit anywhere and float speed, you're going to want to switch over to the C++ file. And you're going to see three different functions right here. The first one is what we call a constructor. So a constructor is called every time the object is created. And when it is created, we're going to want to initialize the value of our speed. So I'm going to have speed initialized to 0.5. The reason I put an F at the end is because I'm telling it it's a float. So once you have that done, you now have speed. But the thing is, a speed without an object to move is essentially just force. It's nothing. So we're going to want to have something to move. So this is where we can kind of refer back to our documentation. Oh, if you are having problem launching Unreal Engine, just take a screenshot of what error you're having, and I can try to figure that out for you. I'm just gonna grab some reference. Nothing happens? You might need to restart your computer. I'm just opening up my other workshop files. All right, so what we're gonna wanna do is include. So back to the PowerPoint where I was saying if you need something, you can just import it. So I want to import a component. And a component of my moving platform is going to be some kind of platform or some kind of mesh that will act as my platform. So I'm going to import a static mesh component. And I'm gonna copy and paste this inside of Discord so you guys can copy. So you want to put that at the top of your .cpp file. So now that you have your static mesh imported, you can go back to your header file, so your .h file. And inside here, we're going to make 3 more uProperties. So first off, like we said, we want some kind of body for our moving platform. So we're going to make a static mesh component that is I named mine mesh. And then we're also going to want a waypoint 1 and a waypoint 2. So somewhere our platform can move to. And then we're going to want a Boolean to tell us when we have reached the first waypoint. So I'm going to go ahead and copy and paste that into the workshop so you guys can copy. So essentially how our moving platform is going to work is it's going to move to the first waypoint. Then it's going to tell us, hey, I reached the first waypoint. Then it's going to go back to the second waypoint and say, hey, I'm not at the first waypoint anymore. And that's how it's going to loop between moving to the first waypoint and then to the second waypoint. So once you have that pasted into .h, go to your CPP file. Well, I guess I call it programming, but it's kind of more like scripting because thanks to Unreal Engine, it makes everything a lot easier. Unreal Engine makes game development easier. Essentially, if we were to make our own static mesh component importer, that would probably be like hundreds of lines. But we did all of it with about 10 lines. Now all we have to do is actually create the mesh. And to create the mesh, what we have to do is say, with my mesh, I want to create a default subobject. And since we made it a static mesh component, it's going to be a static mesh component. And then inside here, I'm just going to name it mesh. So this just determines the name of the object we create. I always keep mine the same as the variable name. That way it's easier to see and set in Unreal Engine. And I'm just going to copy and paste that into Discord so you guys can copy that. We're also going to want to attach the mesh. So we're going to type setup attachment using a hyphen and a left chevron, or sorry, right chevron, which is an arrow. And we're going to say, I want you to be attached to the root component. So what this does is when you select the move tool onto this object, it will move with, the mesh will move with the entire object because you can have several objects inside a single model. And then what I'm also going to say is the root component is actually the mesh. So it's basically following itself. And I'm going to go ahead and paste that into Discord for you. So now we have a mesh. We have a speed, and we have the mesh. Now we just need the logic. So going back to the header file, I want the mesh to move to the first waypoint, and then once it reached the first waypoint, tell us it has reached the first waypoint, and then move back to the second waypoint. So to start, I'm going to put all of this logic inside of tick. So tick is called every frame. A tick is about 60 times a second, assuming you're getting 60 frames per second. And to know which direction our platform is moving, we're going to use an if statement. And we're going to say, if the platform has not reached the waypoint 1, How about you go towards the first waypoint? So conveniently, Unreal Engine already has a set actor location function. So we're basically changing the position to the number we put in here. But if we just set the number where we want to go, it will teleport there. We want to move it in increments. So we're going to do something called interpolating. Interpolating is essentially it starts off slow, which will give our player time to jump onto the platform. It will speed up and then slow down right before it reaches the destination, which gives our player time to jump right off. And I'm going to paste that right into Discord for you. We're going to make another if statement. So we're basically saying, hey, if you reached the first waypoint, tell us you reached the first waypoint. So we're going to say get actor location, and we only want the x value because we're only moving on the x value. And we're going to say if you're at the waypoint, give or take 5 units because it's never exact, tell us. And to tell us, it's just going to change the reach boolean to true. And I'm going to go ahead and paste that inside Discord for you. So we now are able to move to the first waypoint. However, we want to also move to the second waypoint. So if we already reached the first waypoint, we're also going to want some logic for the second to get to the second waypoint. So in an else bracket, we're going to say if you already reached the first waypoint, you're going to do the exact same thing, but instead of going to the first waypoint, you're going to go to the second. So all I have to do is change this 1 to a 2. And I'll paste that into a Discord for you as well. Or this bit here. And we're also going to want to be able to tell us when it reached the second waypoint, so it can set reach to false. That way, we have a never-ending loop. It starts us off as false, becomes true, and becomes false again. So we're going to go ahead and copy this, or actually I'm going to copy it from my other one and paste it in here. So it's the same thing. It switched the 1 for a 2, but since it's moving in the opposite direction, we are also switched the commands. So instead of saying greater than, we want it to be lesser than. Instead of subtracting, we want it to add because it's the complete opposite. Instead of making it true, we want to make it false. So I'll go ahead and paste this into Discord for you guys to copy. Oh, hold on. All right, so now that we have all our logic, what we want to do is do Control S, so file save, and make sure we have that on both our header file and CPP file. And when we close this, we also want to close Unreal Engine. So file, save all. And the reason we're doing this is to refresh everything. So when I said, remember where you installed your project, you want to navigate there. So for me, I installed it on my F drive, inside my personal projects, inside my Curious Workshop, and here I can find my solution file. I actually wasn't supposed to close the Visual Studio file. So once that has opened, I can hit this button right here, Local Windows Debugger. So what this does is it launches Unreal Engine without requiring us to go through the Epic Games Launcher. And the reason we want to do that is because this project is C++ based, not Blueprint. So it's very important that we're able to constantly hot reload our project and have our Visual Studio do all the rendering and processing for us, not the Epic Games Launcher. When we launch up, we launch into the demo file we were given, which is why we want to go navigate to our maps folder. And here we see main map. So I'll just give you guys a second to to run your Unreal Engine, and then navigate to the maps folder and go to main map. Luckily, when you save your map, it also has this built data, which makes it even faster to load into your maps. So now that we're here, but we don't see anything yet, that's because we haven't created it yet. We can go to our C++ classes, open this up, and go inside Curious_Workshop, which is what I named it. You might have a different name. And here we see Moving Platform. What we're going to want to do is right-click our content folder, go to New Folder, and I'm going to name mine Blueprint, or Blueprints, because there's probably going to be more than one if you're making a game. And then I'm going to go back to my C++ classes and right-click my moving platform. And I'm going to select Create Blueprint class based on moving platform. And the name convention for blueprints is writing a BP followed by an underscore. So now we know it's the blueprint version of the moving platform C++ class. And I'm going to store that inside my blueprints folder. Once you've done that, you will have a blueprint editor open up. If you don't see what I'm seeing, that's because you're not in the full editor. There should be a blue button that says Open Full Blueprint Editor. If you click that, then you will be able to see the blueprint. Now, once we have this open, we're going to want to click on Mesh. This is the mesh we created. I named my variable Mesh. You might have named yours something else. We can go to the Static Mesh property. So we're going to want to select the mesh, go to the Static Mesh property, and I'm going to go with the 1 meter cube mesh. And ta-da! There it is. That's our mesh. Now we have something to drag in. And I'm going to place this right here for now. I'm going to use my my art tool to just shape it into a platform. But what I'm also going to do is I'm going to pull in 2 empty actors. So my first empty actor, I can select using the world outliner. It's going to have the exact same location as my moving platform. Moving platform. So I'm going to copy the X, put that into my first moving actor. I'm going to copy the Y, put it into my moving actor, and copy the Z, and put that into my actor. For our second actor, we're going to want to have the same Y and Z as the platform because we're only moving on the X-axis. Now that it has the same Y and Z axis, all we need to do is slide this to where we want the platform to move to. So about here is fine. Once you have that done, you can select your BP moving platform. You can see the variables that we've created: the speed, the mesh, waypoint 1, 2, and the reached boolean. However, these two are empty. So we want to put our first actor into waypoint 1 and second actor into waypoint 2. Now when I play, we can see the moving platform move. And it's already over there. So what I'm actually going to do is under play, I'm going to do start the player at the current camera location. Oh no, it's moving way too fast. And now we can see we're traveling to our location. It's actually moving a bit too slow for my taste, so I'm gonna change the speed. And I might be able to see it from here. Yeah, now it's a lot quicker. And now we have a moving platform. I think we're running into a bug here where it's not moving all the way. And I think that's because this is too close to here. So, yep. Now we have a moving platform that moves to our second floor. Oh, that's weird. It stopped right there. I'm just going to check my code here. So I'm just going to restart it real quick. I saved everything before I did. And I'm just going to post the code again into the workshop. I'm going to go to maps, main map. Oh, I didn't save. C++ classes, double click. Or just drag this in, reshape it. Move into empty actors. Have the first actor have the same coordinates. And have the same z-axis and y-axis as the first actor. And we'll have it right there. And I'm gonna give that a test. Getting a little error here. Oh, that's right. That's because I forgot to tell it where I put the empty actors. So a large part of game development is quality assurance because you're going to get all these little details wrong all the time. And to break into the game development profession, you usually start as a quality assurance tester. So your job is literally just play testing video games. And you find all these little bugs and you fix them. And I think there's actually a site under Ubisoft called playtest.ubisoft.com, and you can actually start working for Ubisoft Toronto at the age of 16, and you can test all these video games. And it's good having Unreal Engine a part of your resume when you apply because it allows you to start working on games like this. And I believe they're actually expanding their mobile game team as well in Halifax. So if you ever want to move to Halifax and work on platformer games like this, you would have the perfect portfolio with this workshop. So I'm just going to copy this. Oops. This is basically the end of our workshop. We're just making a moving platform. And we're going to put this in here. And moving platform. I just forgot to put in the empty actors within the blueprint. And before I forget, we want to save all. So let's give this a try. Oops. There you go. Or maybe not. But looks like we're out of time here. I just have a little bit more slides. So what we did was grade blocking. We used non-textured objects, um, such as this, and we placed it to where our puzzles we want it to be. We did have a chance of making some of our own textures, like the red material. However, this texture can be further improved. For example, if the theme of my game was heaven, so maybe I could make this a moving cloud, and I could make this a static cloud that doesn't move. This is what the 3D modeler will be doing. And a great part of that is when you're grade blocking with something like this, since it's such a basic object, you can see the scale right here. And you're able to measure the size. So when you're making a level and you say, "Oh, the workshop can run until 9," awesome. Well, this is actually almost the end, anyways. Um, you're able to take the measurement of this size because everything inside Unreal Engine is measured in meters. So the metric system. So if you're located in the US and whatever other country that uses the imperial system, you're going to have to learn the metric system because everything is measured in centimeters. And when you use software like Blender or 3ds Max to create models, you want everything to be in centimeters or even meters. So that just blocks out everything. So this is a great example of blockout. So you can see some basic buildings like this, um, completely blocked out. But this is probably not what you want for your end game. There's no texture, there's no lighting, there's not many other things. That's where the 3D artist who's very professional in Blender or 3ds Max come in, and they create it for you. Great blocking also allows game developers to continue working on the project and not wait for the art assets to be finished. It also allows for experimentation and can be consistently changed. For example, maybe I don't want to go on the x-axis. Maybe I want to go on the y-axis. Maybe I don't want to go in a flat plane. Maybe I want this to be higher. And instead of programming it to move on the x-axis, I want to move on the y-axis. This is why grade blocking is done. We didn't actually spend too much time on this. We only spent an hour. And with that, it allows us to change game mechanics. Believe it or not, many of your favorite games probably had planned game mechanics that were completely eliminated because it was seen as too linear or just not needed. It could even ruin the game. That's why grade blocking is important. We're not really losing too much time. And when games like Cyberpunk take like 10 years to be created, time is a very valuable asset for your fans and people who want to buy your game. Another thing is blueprinting. So we did everything in C++. However, oops, wrong Visual Studio. We did everything in Visual Studio C++. However, it's also possible to make it in blueprints. So I'm going to actually have something for that, for blueprinting. Blueprinting is a very fast way of programming because it's all visual. It's essentially like Scratch Junior, if you ever heard of it. You essentially just connect nodes to others, and it's very easy to learn, especially if you find yourself not very proficient at programming. Um, it's also very convenient for grade blocking because it's good for prototyping. If you want to propose, say you're working on Valorant and you're proposing a new character, and you want to propose a new superpower, you would want to quickly blueprint that out and show it to your manager. Blueprinting can be very powerful. Some games are entirely made in blueprinting. It's because a lot of people who are designers, who have great ideas for video games, don't know how to program. But they do know how to connect lines. And That's why blueprinting is such a powerful and great tool. So we're going to do that. We're going to go to volumes, which is located in the place actors inside volumes. And we're going to use the search classes tool, and we're going to type in trigger. So we're looking for a trigger volume. And I'm just going to size it big enough because it's actually invisible that I'm able to walk into it. So now we have a trigger volume. I'm just going to place it right here. Yep, so now we have a trigger volume. So with our trigger volume, what it does is it triggers something when it detects the player inside. And to do that, we're going to need blueprinting. So we're going to go to blueprints at the top here and go to open level blueprint. So again, we're going to go to blueprints, open level blueprint. And this is usually not touched very often because this is the blueprint for the entire level. And this is used for mainly prototyping. However, when you're making small scale games such as this one, it's completely fine to make a level, to touch the blueprint level, because you're probably going to have multiple levels of different obstacles. So to start, we're going to make sure we have the trigger volume selected. And to make sure you do that is by looking into the world outliner. So with the trigger volume selected and the blueprint editor open, we're going to right click, and right here at the very first option, we see add event trigger for volume 1. And we're going to say inside collision, add on actor begin overlap. So it's essentially saying when the player is overlapping with the volume, call the block of code that is connected to this. So we're going to say create a widget. So what we're going to do is when you go into this volume, it's going to say, welcome to the first puzzle. And to do that, we're going to want to create a widget. However, we're also going to want to know who is going to see that sign. So what we have to do is right click the empty space. With the search bar, we're going to type get player controller. So we're going to find the screen of the player controlling the player or the character. And with that, we're going to say add this widget to the viewport. So add to viewport. And then the return value will also be connected to target. So when you touch the volume, create a widget, add it to the screen of this player. But we also want to be able to do other things other than just see the sign. So we're going to say set mouse cursor or show mouse cursor. Not sure where it is. Get mouse position on viewport. That might not be it, but we'll roll with it. What we also want to do is have another one called event begin play. So event begin play is called as soon as the level is started. So this is what you use for initializing. So if you want certain things to move around on your screen as soon as your game starts, you're going to want to call event begin play. And we're going to say remove all widgets. So That's because we don't want to be able to see this widget until we touch the volume. And to do that, we're going to want to make sure the widget is not there. And we're just, actually no, stopping at remove all widgets is fine. But yeah, removing all widgets is fine. Compile, save. So it's saying we have an error. We don't have the UI created yet. We don't know what to create. To do that, we're going to want to go to content. We're going to want to make a new folder, and we're going to want to call it UI. And this is for all you designers out there to create UI. So right click in the empty space and go to user interface and go to widget blueprint. And I'm just going to say start. This is going to be my starting UI. So if we double click start, something comes up called the widget editor. It's very much similar to our blueprint editor. And this box here represents your screen. So what we can do is we can place a border on your screen. And I want it roughly this size. This might be a bit too big, but that's fine. And I want to make it a different color because white is kind of too bright. So on the right side here, I have my details panel. And inside content, we're able to change the color. And we can get a different color here. So I'm gonna want to make it, green for start. Oh, it was actually brush color. Green for start. Now there's no text on here. We're gonna want some text. So I'm gonna say text, and I'm gonna put that inside my border. With this text, I'm gonna say welcome to level 1. And what we can do is make it horizontally and vertically aligned to the center, so it's right in the middle. And the reason it's green is because the content color was defined here. I want to keep that white. So welcome to level 1. Nice, bright green, and welcoming. Except, how do we get rid of it? So we're going to want a button. Oops. We are going to want a button added inside the border. And we're going to want to place that button. Oops. I'm going to try that again. I want a button right here. Nice and big. I want to place that inside here. Or I'll go like this. Huh, that's weird. Whatever, that's fine. So I want to program my button to hide all of this once it shows up. So what I can do is I can go to the very bottom of the details panel for this button, and there's an event called onClicked. And I can basically say, when it is clicked, do this. So I want to say set visibility. Set visibility to hidden. But what is it targeting? It is targeting, oops. It is targeting this border right here. So I want to right click, or at the very top here, where there's a button that says is variable, I want to turn that into a variable. Then I'm gonna go back to the button, scroll to the bottom, and click view the onClicked, and say, hey, with this border, this is what we want to make hidden. And you probably want another one here as well. Set visibility You also want to make the button hidden as well. So you want to make the button and the border hidden. And you're going to save, and you're going to close that. And now you're able to say what you want. So you're going to want to create the start. Let's give that another compile. Now it's happy. I'm just going to close this. Oops. Get mouse position on viewport. Pretty sure that's the one we want, but I believe it might have been called something else. Well, there's only one way to figure out, which is quality insurance. So we're going to hit play. And there we go. Welcome to level 1. And as you can see, that was done very quickly. So what's correct? And that is what blueprinting is. It's done very quickly. Usually later on in your project, you will want to be able to convert that to C++, so your programmers can have it joined down in the system with all of the UI throughout the level. So you might have a health UI, you may have different UI. It's better to have that all allocated under C++. However, when you're prototyping, what matters more is getting it done as soon as possible and having something be able to be seen by your manager, and they can either accept or decline your proposal for a feature to be added to the game. Finally, now that you know how to grade block, blueprint, and do a little bit of C++, you're going to want to learn how to become a better game developer. To become a better game developer, you're going to want to participate in game jams. You're going to want to be able to make as many games as possible. And I can attest to this because your first maybe 10 games or so is going to suck. We all want to create the next GTA 5, but unfortunately that cannot be done on your first project unless you're like Mark Zuckerberg, who created Facebook. Your first few games are going to suck, but it's great because every single time you make a project, you learn from it. And whenever you finally have something that's you think is good, you can add it to your portfolio. And you're going to want to have a portfolio either on itch.io, LinkedIn, or even your personal website, because there's no way to test your skills other than seeing what you've already created. So essentially, they're not always going to give you a programming test like many other jobs. So if you're looking to become a back-end web developer or a full stack developer or even a software engineer, they usually give you all these complicated puzzles to solve. When you're a gameplay programmer, you're still going to be tested. You might be given a test similar to what a software engineer gets, but that doesn't determine your ability at making games. That can only be seen through your previous work. That's why your portfolio will work. Because game development is an arts industry, much similar to Hollywood. They want to see your past projects. What movies have you been in? Were they any good? I don't know until I see your portfolio. But the thing is, who do you show your portfolio to? You want to show it to recruiters. And it's really hard to find game developing jobs, at least in Canada, because there's not a lot of that. But what we do have a lot of in Canada is game conferences. They're mainly hosted in Quebec, Montreal. So you want to go to these conferences. You want to meet people. For example, I believe tomorrow, if you haven't signed up already, there's the E3 conference. Most people watch the E3 conference to see a new game. For example, Bethesda has some news about Elder Scrolls 6 if you're excited for whatever is going to come after Skyrim. However, game developers are going to say, I want to meet the people who made Elder Scrolls 6, and I want to be able to work on Elder Scrolls 7. I want to meet the recruiters. I want to meet the team. I want to get hired. That's why you go to game conferences, and that's how you meet people. And you essentially apply for jobs at these conferences, and you meet recruiters, and you can also add them on LinkedIn. They will follow your progress of your portfolio, and that's how you find jobs. So that's the end of my workshop. It didn't go completely to plan, but fortunately we have about 5 minutes left for any questions you might have. But that's essentially an introduction to Unreal Engine. It takes a lot of work. It's a lot of programming. But if this is what you want to do, and this is what you like, game development can be really satisfying. Unfortunately, for a lot of people, they usually give up on game development because they think it's a lot of fun. It's a lot of playing video games. And it's not always fun in games. Even if you're a gameplay tester, you're going to be playing the same puzzle over and over and over to find bugs, even if it's just jumping in the same corner for 4 hours because your boss said so. All those one or two bugs you find in those 4 hours can be extremely detrimental to the project, which is why we need to test. Here is an example of Ubisoft. So last March, Ubisoft does something called Ubisoft Next, and they have you create a game to prove your skills. This is what I created for a puzzle piece. And essentially, oops, I skipped over it. Oops. I created all this code, which is about 10 or 20 lines of code, just to move these enemies on the screen. Unfortunately, that's a lot of time. And Ubisoft also happens to measure time. You have to be the best, the best of the best. And to do that, you gotta go to Game Jams and practice. So if you have any questions, feel free to send it to workshop. Otherwise, or unmute and say your question. Otherwise, you're basically free to go.